Number 60. Label each of the following statements as true or false. Correct any false statement to make it true. So we're given two statements here. Let's read the first one. A solution with a pH of 9 is 3 times more basic than a solution with a pH of 6. So you need to know what these pH numbers mean. And over here on the right, you can see the pH scale ranges from about 1 to about 14. The lower the numbers, the more acidic it is, and the higher the numbers, the more basic it is. But it's actually a quantitative scale that tells us what the proton concentration is in water. So if you have a solution whose pH 1, then there are 0.1 molarity of protons in water. And if the solution is pH 2, then the concentration of protons is 0.01. pH 3, it's 0.001. pH 4, 0.0001, or we can just write 10 to the minus 4 to make it a little simpler. Likewise, that would be 10 to the minus 3, that would be 10 to the minus 2, and 10 to the minus 1. So pH 5 is 10 to the minus 5 molarity protons. So you can see as the pH numbers go up each time, the proton concentration is 1/10 of what it was before. So pH 1 is 10 times more acidic than pH 2, but it's 100 times more acidic than pH 3 and 1,000 times more acidic than pH 4. Now, these two are I'm sorry, in number 60 are dealing with how basic a substance is. So we're concerned with not the proton concentration, but the hydroxide concentration. Well, there's a simple relation between proton and hydroxide concentration. The two concentrations are tied together. If you know the proton concentration in a solution, then you know it's hydroxide. And as the proton concentration decreases, the hydroxide concentration increases proportionately. And here are the corresponding hydroxide concentrations. If the proton concentration is 10 to the minus 1, then the hydroxide concentration is 10 to the minus 13. Okay, if the proton concentration is 10 to the minus 2, the hydroxide concentration is 10 to the minus 12. If the proton's 10 to the minus 3, then the hydroxide's 10 to the minus 11. If this is 10 to the minus 4, then that's 10 to the minus 10. And hopefully you can see that in all of these, the exponents are adding up to negative 14. I'm just going to write that up here. Negative 14. Okay, add up the exponents. Minus 4 and minus 10 give you negative 14. Minus 5 and minus 9 give you negative 14. And they do that the whole way through. So as the proton concentration gets smaller and smaller and smaller, the hydroxide concentration gets larger and larger and larger, but we're able to know what the hydroxide concentration is. So let's look at pH 6 versus pH 9. Now pH 6 is how many? 1, 10, 100, 1,000 times more acidic than pH 9. So we could say that pH 9 is 10, 100, 1,000 times more basic than pH 6. So the part A is actually false. A solution with pH 9 is 1,000 times more basic than a solution with pH 6 because it's 3 numbers away. What's part B? A solution with pH 8 is 100 times more basic than a solution with pH 6? Yes, that's correct. When you're comparing these two, this is 2 places away from that one. So pH 7 is 10 times more basic than pH 6. pH 8 is 100 times more basic than pH 6. So So we're looking at the hydroxide concentration now. So that one was true.